Okay guys, let's take a look at today's lesson. We actually have two topics to cover today. One is solving trig inequalities, both of which we're going to be using a calculator with. Our second one is Snell's Law of refraction. Sounds exciting. Okay, so let's look at and talk about trig inequalities first. What we're going to do is we're going to use our graphing calculator to help us to solve the trig inequalities. That's what we're going to be doing today. We're going to graph each of them and then locate the endpoints of each intersection in the graph and find the intervals within which the inequality is true. That's what we're going to be doing. The calculator screen would look something like this. Actually, we're going to do this exact problem on the second page. I just wanted to talk just a little bit about the calculator screen. This little triangle right here, you are able to scroll over to the left of your Y1 and Y2, and you would press enter. Well, I guess it depends on which kind of calculator you have. I'll show you in just a moment. The bottom, if the triangle is on the bottom, that's less than. If the triangle is on the top, that's greater than. So that's really what you need to know about the triangles, is that if the triangle is on the bottom, it's less than, and if the triangle is on the top, it's greater than. And then we'll actually do a problem in just a moment from that. So that's the trig inequalities. So let's look at Snell's Law. What we're going to do is I'm going to go through vocabulary first. I mean, really, this is heavy vocabulary, heavy on vocabulary. The actual process that we're going to be using is not that difficult, but there's a lot of vocabulary that we need to get through. All right, so what this concept is when light passes through anything, a window pane, a sheet of ice, when it passes through something, it changes its speed and its direction. And so this really smart guy, I'm guessing his last name is Snell, came up with the formula for which that works. I mean, that the light changes. So his Snell's law of refraction looks like this: sine of theta 1 over sine of theta 2 equals v1 over v2. And so this is a formula that he created. So let's pull it apart and look at what each of those things are. Let's talk about v1. v1 is the speed of light in the air. Okay, that's what it is, the speed of light in the air. And v2 is the speed of light as it passes through the glass. Now that's our rendition. As it passes through glass, v2 could be the speed of light as it passes through a sheet of ice, whatever the scenario is. So v1 is the speed of light just in the air, and v2 is the speed of light as it passes through whatever medium it's going to be passing through. Theta 1 is the angle of incidence, and we're going to look at a picture in just a moment to see what that actually means. What's an angle of incidence? And theta 2 is the angle of refraction. Okay, so we're just going through vocabulary. We've kind of indicated what each of these were. You know, v1, v2, theta 1, theta 2. We just talked about what they are. Now let's talk about this ratio, this v1 over v2. Many times we're just given that the answer, I mean, what the ratio is. So that ratio is known as the index of refraction. So another vocabulary word. It's like I was saying, this is heavy on vocabulary. That is the index of refraction when light passes from air to glass or whatever. So here is the value of this ratio. The value of the ratio as light passes from air to glass is 1.52. So that's what you would replace. You would replace this part right here, this v1 over v2, with 1.52 if your scenario was that the light is passing from air to glass. That's what you would do. If the light is passing from air to ice, then the index of refraction is 1.31. Again, that would replace this v1 over v2 in the formula, if that's what we were doing. So there will be times when we're given the index of refraction. It's going to be a number, and we would just put it right here in the formula. And there will be times where we have to find the index of refraction. We are given the angle measures, and we have to find the index of refraction. There's two different kinds of things that would happen here. Okay, so now let's look at a picture. So in this particular case, this would be, you know, a piece of glass, the window pane. This is a sheet of glass. This is a vector. I know we really haven't talked about vectors before, but light is a vector, right? And except basically this velocity is a vector. So it's coming in like this, and it's creating this angle. Theta 1. Theta 1, we said, theta 1 is the angle of incidence. This is the angle of incidence. Now, you know, as you probably know me, unfortunately it's made with the vertical. I don't like that, right? But that's just what it is. This angle is made with the vertical. It is not made with the horizontal like, you know, every other thing, well, except navigation. So it's made with the vertical. This is the angle measure, angle of incidence. So as the light passes through whatever this happens to be, in this case glass, it changes direction and it changes speed. Okay, that's what his law is showing. Changes direction and changes speed. This angle, of course, also made with the vertical, made with the pane of glass. That's our angle of refraction. That is our angle of refraction. So they're going to be calling these things by name. Angle of incidence, angle of refraction, and you just need to know which one they're talking about, because it's going to make a difference in the formula, right? So we'll make a difference in the formula. So you just need to know what the vocabulary. All right. And so that is an overview of the two things that we're doing today. Any questions about the overview? Okay. So then let's move to, we just have one example of each. And from the overview, you're probably thinking, oh my gosh, that's Snell's Law. It's going to take so long. It's actually the fastest one. It's the inequalities that are going to take some time. So let's set it up. So the first one, we're going to graph and solve the sine 2x greater than or equal to cosine x. Okay, we're going to be using our calculator. So the first thing we need to talk about is how do we enter it in the calculator? What do? So what we do is we take this sine 2x, okay, we're going to keep this greater than or equal to sign right here, and we're going to make it y1. We're going to have to put one side in y1 and one side in y2. So that's how the easiest way for me to explain that this is what's going to happen with the sign. Notice how I'm basically just covering this part up and replacing it with a y1. So now let's work on the other side. Basically, it's the same kind of scenario. I am just covering this side up and replacing it with a y2. Notice that the inequality sign is still greater than or equal to. Okay, so that's how we're going to translate it from paper to calculator. Are we okay with that part? Now, of course, your calculator has the y on the left side. Right, so this, I'm just going to reorder it so that it's really obvious what we're going to be doing. So it's y1 is less than or equal to sine 2x. Okay, so that's what we're going to be doing. So the y1 is the less than. Which of the triangles are we going to put with this one? The one underneath, right? Less than is the underneath triangle. And y2 is greater, so we're going to use the greater one, the triangle that's above. Okay? All right, so I need to erase that to get to my calculator. Are we okay? Okay. Now, go ahead and make sure your calculator is in radian mode. It's not going to do a very nice job of graphing if it is in degree mode. So I'm just going to start over again so we're in a clean slate. So, all right, so y1. y1 is sine 2x. Okay, so I'm going to scroll over. Now this calculator has color. It's not like my regular calculator. On my regular calculator, what I would do is I would go over here and I would hit enter until I get the right triangle that I want. But with the colored ones, you actually are able to change colors, which I guess is kind of cool. I hadn't really thought about that. I don't have one like this, so that's kind of cool. This one allows you to change the color. If you don't like what color it's set, you can change it. I want to get to this part right here where we're changing the line. So we're going to go down here, and I'm just going to arrow until I find what I want. See, we have lots of options. I don't know if you've ever played with this before. I, of course, have. You know, I'm a big nerd. I think it's fun. But you can play and change what it looks like. We want, what do we want? We want the under one. So there we go. There's the less than one. And then we would, you know, hit enter enter, and I have the less than 1. Okay, and then we would go down to y2, and I would do that same thing over here. Are we okay with that? I'm not going to go through that. That's what we would do. We would change this, and this would need to be the triangles in the top part because it's greater than. And this one was, what was that, cosine? Yeah, cosine x. When I first did this, I was in degree mode, and it was terrible, so I'm going to just make sure my mode, okay, I'm in radian mode. That's important. Also, I need to pay attention to my window. Okay, I like to, it depends on what problem I'm working, but kind of the standard is like 0 to 10, so that I get more than one normal period. That's what I like to do with my x, 0 to 10. I mean, you could do whatever you want. My y values, we know that the min and max for those are 1 and -1, so if you leave it at -10, 10, you're going to not see a very good picture. So what I did is I changed it to a min of y min of -2 and a max of 2, just so I could see the picture better. That's all. Okay, so that's what I decided to do. You can kind of set it however you want, but I'm just giving you what I would do. So then we're going to graph it. Okay, so what we're looking at, the solution is the intersection of the two. So, and this was a little bit of a confusion earlier today. This right here is the answer, right? These are the answers. The answers that are all of that. That is the interval that we're looking for. So in order to write my answer, I'm going to have to find this x value and this x value, right? And then I would, put whatever that is, depending on open or closed bracket, depends on the circumstance, but that would be the answer to this interval, right? I would find this x and this x, I'd put them in brackets or parentheses, whatever we're doing. If this is all solutions, I would have to, which ours is, I would have to put, plus whatever the difference. So sometimes it's not going to be really easy. Sometimes we're going to be mixing like double angles and single angles and triple angles, just all kinds. So how would we know what the difference is? How would we know how often it repeats? Well, we would look at our graph, right? So we see this little weird part right here and this bigger part. What do you think this is? Doesn't this look exactly like this? It's exactly the same, isn't it? So I know that the distance between the beginning of this one and the beginning of this one is how often I'm going to repeat, right? That's my repeat. I would need to find, if I didn't know, I would need to find these two values and subtract them so I would know what the period is. How often does it repeat? Does that make sense? You're using our calculator to discover those things. Because I don't want you to have to do all of this by hand. We're going to do some things by hand, but I don't want you to have to do that by hand. Use your calculator. Are we clear on what we're looking for? We're trying to write where this is true, where our problem was where sine 2x is greater than cosine 2x, and that's everywhere it's shaded, right? It's in these intersections right here where we're shaded. Okay? All right, so let's continue. We would need to find this location right here. So we would do second calc. We would do our intersection, number 5. And we would just scroll over there, till we got right over the intersection. Okay, right here. Okay. Oh, great. There we go. So then we hit enter, enter, enter. And so I'm just going to kind of write this up here for our purposes. So the first one was x equals 0.5235. And then we're going to find, these are going to be one intersection. I'm going to find this one right here. Okay, so let's do that. So let's do second calc intersect. And then we're going to go over here and find where this section ends. It should be right there. Enter, enter, and enter. Okay, so let's go ahead and log that. So that is at 1.5707. All right. Then we would do the same thing for this section here, because we have two sections that repeat over and over again, right? Not just one section. Sometimes you'll have one that repeats, sometimes two. So I'll just tell you I've already done that. I'm just going to write those answers up there for you. So this intersection is 2.6179. And the next intersection is 4.7123. And this is another interval. Okay. So what we're going to need to do when possible, and I will be sure to write the directions on an assessment for you. Today's lesson is the last lesson that's on Monday's quiz. Okay, so I'll write. You would either need to, I will either let you leave it as a decimal, or I will want you to put it in exact form. And let's explain what exact form is. I'll go back to the problem. Are we okay with this part right here? Everybody good? And we have all that written down because that's getting ready to go away. Okay. So let's go back to the problem. And so when it's possible, in this case it is possible, just to get some good extra practice in, let's go ahead and where would these intersect? Where they're equal, right? So let's go ahead and solve these. So this, I'm going to turn sine 2x into 2 sine x cosine x. And then I'm going to move the cosine over, right? So I'm just going to solve that so I can get the exact values. Sometimes I'll have you do this and sometimes I won't, but I will indicate so that it's clear. So we would factor out a cosine, it's just good extra practice. 2 sine x minus 1. So we have cosine is 0 or sine is 1/2. So cosine is 0 at pi over 2 and 3 pi over 2, etc., etc. Sine is 1/2 at what, pi over 6 and 5 pi over 6. So it just took a few seconds to get the exact values. Now we need to figure out on our with the decimal approximations which is which. So a few confusions there. Now how am I, if I want to know the decimal approximation from pi over 2, you're going to have a calculator. I would just hit pi divided by 2, right? Just hit enter, and that would tell me which one that was. Are we okay with that? That's all I would do, is just put those in and find out what the decimal is. When I do, and now this one is for all. I have a few on the daily work where it's just an interval that we're solving for, but this one is for all. So the first one is pi over 2. And our period is plus 2 pi n. Really, because I changed all these to single angles, didn't I? They're all single angles. So our normal period for those is 2 pi. So that's the x value of my first, that very first one that we did, is pi over 6. And then it goes to pi over 2 plus 2 pi n. That's my first interval. My second interval is 5 pi over 6 plus 2 pi n to 3 pi over 2 plus 2 pi n. And if I wasn't sure if this was 2 pi, I would just do what I was explaining before, is check the difference between the two endpoints where each of these little sections begins and ends. So let's talk about brackets versus parentheses. Since this is greater than or equal to, I would use brackets, wouldn't I? Because they're equal at those places. What if it was just greater than? Would I use brackets? No, I would use parentheses. Unless, like there's some of the daily work where we have an interval, unless our interval cuts in the middle of one of the intersections, then we could use parentheses, or I mean brackets, right? So if we're moving along, you know, so say that's our intersection, but this is where 0 is, right? And I am looking for 0 to 2 pi, you know, that's usually what I've given on the daily work, then this part is true, right? This one is bigger than this one, so I would do a bracket at that location. At this location, I would do a parenthesis. Does that make sense? That was causing confusion earlier. So here, since it's the beginning of my interval and this function is larger than this one, I would bracket this in, but at the places where they're the same, the exact places, that would be a parenthesis. Okay? And I'm seeing maybe we are okay, maybe we're not. We'll just keep working on that. Okay? Hopefully we're okay. Alright, so that is our first problem. Now let's go to Snell's Law. So if the angle of incidence is 20 degrees, okay, we need to know what that is, right? So the angle of incidence is this one, 20 degrees. As the light passes from air to ice, what is the angle of refraction? So they're asking for theta 2. That's what they're asking for. That's what they're asking for. So our formula is sine of this angle, right, of the angle of incidence, which is 20 degrees, over sine of the angle of refraction, which we don't know. And they're saying it's passing from air to ice. We have a number for that, don't we? We have the, what was it called? Do we remember? Index of refraction, remember that? We have the index of refraction from air to ice. What was that on the other page? 1.31, right? Wasn't it 1.31? 1.31. And so what our job is in this particular problem is to simply solve for this, solve for theta 2, our angle of refraction. That's all. So we just use our regular old trig solving techniques where I'm going to cross multiply, I'm going to isolate. So I get sine of, you know, theta 2 equals sine of 20 degrees over 1.31. And then I just use my calculator and I get that the angle of refraction is 15. Now of course we need to be in degree mode because these are in degrees. Just remember to go, this is in radian mode and this is in degree mode. So that's our angle of refraction. So see, those problems are really not bad, right? We just need to know how to set them up. Okay, how are we doing?